Hello, my name is Beltran, and as we've been introduced, I'm a work-learn student in the Interactive Orchestra project. And for today, I'm just going to be talking a little bit about just the development process, as well as the conception of the project, and future prospects of where we think this project can go. And so we've covered this a little bit so far. So the Interactive Orchestra project has changed over the past year or so. It used to be a much more different experience than it is today. So back in around a year ago, it was going to be more of a project about just viewing an orchestra with a 360 video used by studio. We have a video that I'll be showing really quickly in a moment. And Dr. Jirard approached us at EML, and he wanted a more hands-on experience, something that conducting students could use so that they could actually practice and learn conducting in a much more controlled setting. I don't know if you've met people practicing their own instruments. It doesn't exactly sound pleasant. There's a lot of flats, a lot of sharp notes when you're practicing, your instrument. And imagine having to round up around 20 plus 30 people in order to practice conducting. It gets a little bit cumbersome. So this is the idea of the experience, is to create something that allows conducting students to have an experience in which they can actually practice and have some good feedback without having to organize an entire orchestra. An orchestra such as this one. So this is the original conception of the project, which is where we got kind of our inspiration from. And if we just get past the intro, we'll get an idea of, let me just skip a little bit. There you go. And so this was the original conception of it. This video, you can find it on UBC EML website if you want to take a look at it. And you can rotate around and see all the members of the orchestra. And now our goal is a little bit different, because we want to mimic what he's doing, but in VR. And so we assembled a team of a lot of students and volunteers in the Emerging Media Lab, each with a lot of different backgrounds from computer science, cognitive systems, psychology. And we also had the help of our consultant, Peter Cow, who works in one of the oldest VR studios here in Vancouver. He gave us a lot of really great insight and industry advice, as well as best practices. And well, we got started. And one of our first meetings with Dr. Jirard, as was mentioned, was that he came into the lab, and we used this app available on Steam called Tiltbrush, which allows you to draw right on 3D space, essentially a real-time sculpting. And he drew for us all the different gestures that could come from conducting. Very basic gestures, just something very general. What we found as we started speaking with Dr. Jirard a bit more was that the gesture when one is conducting varies widely depending on a time signature, that being, I don't know, the general music terminology in the room, but generally a bar is either in 4/4, so that's 4 counts of 4 beats, or 4/3. Also, the dynamics might change the gesture a bit, so that is, for instance, a legato beat has a legato style, let's say, has a more smooth transition between notes, while a staccato is more accentuated. The size of the orchestra can also affect the shape of the gestures. And so for the sake of the project, as we wanted to have more of a proof of concept and something that we could just show works and we could keep it controlled, we decided to have our gesture of choice as a 4/4 beat and legato, which is shown right now. That's the beat that we are trying to aim for. So what's the first step that we decided to undertake? We decided to go for gesture implementation. So we wanted to be able to detect the gestures that users, gesture with the Vive controls that we're using. We decided to use Vive HCC because we're just all much more comfortable with it. It also has built-in accelerometers, which I will get to in a minute. And right here we have a video of this library that we found online called AirSig. And AirSig, it's kind of self-explanatory if we watch this video right here. It has some built-in signs that it can detect the gesture that you create. So for instance, it drew a C, it drew a heart, and it tells you a score of how well you matched your gesture with that built-in sign that is in that library. So the fun part about AirSig is that we can input our own gestures. And so we got this 4/4 legato beat. We broke it down into 4 gestures, labeled as such. So 4/4 L, 4/4 legato, 4/4 L, 1, 2, 3, 4 for each beat. And we also have the prep beat, which the prep beat is essentially the beat that precedes the start of a piece. So for the sake, a 4/4 legato beat will kind of look like this. And the prep beat that prefaces it when you start a piece will kind of look like you rising to get to that first position. Cool. Once again, in order to reduce the scope of the project, have something functional and working, Dr. Jirard recommended that we use the piece O Canada, the national anthem, as many of you may know. Because it's a very simple piece, it's in 4/4 time, was something that we could easily work with. It has a BPM of 93, and therefore, if we go 60 divided by the BPM of the current piece that we're working on, we get the beat time that we're working with. And so, if you saw earlier in the video for AirSig, the way that the gesture is collected is by pressing a button, then letting go, and then the gesture will be collected. Instead, we changed that up a little bit in the system that we started building in Unity. We made it so that the gesture will be collected at every beat time. So as you start performing a gesture, every 0.6452 seconds, in this particular case, the AirSig will cut off your beat, and then it will start recording. Well, not start recording, it will record the gesture that you just did and give you a score. Did you do the gesture right? Did you do it incorrectly? With this score in mind, we also had a third-party software called Wise, which is a great software that uses, that's just really good at anything audio-related and can be very easily implemented into Unity. And it has this great feature that we thought was very important for this project, where usually in DAW or Unity's built-in music settings, or audio settings rather, slowing down or speeding up a piece will also affect the pitch. If you're trying to get some actual feedback as to how fast you're conducting an orchestra, if an orchestra is going faster, all the instruments are not playing at a higher pitch, it kind of ruins the music. So Wise is able to actually slow down and speed up tracks without affecting the pitch at all. So we thought that that was perfect for this project. And so Wise was implemented. And according to the score of the gesture that I just showed you, we are able to modify the playback speed of the song. And we were able to have a short little demo. Unfortunately, the audio is not available at the moment. But here you can see the environment that we have built. It's kind of wide and sparse, very nice and kind of epic. And we have a small stand right in front, a 3D model baton. Here's a gesture that indicates the prep beat. And so the player or the user follows that gesture, and you see how it changed right then. If audio was in this video, that's when the piece would start. And it changes to all the way to the 4 gestures that we have defined. Each different color represents one of the gestures that we broke down and defined as yes, these are the beats that we are going to use for the 4/4 legato beat. And that's generally how the experience works as of now, with the displayed BPM of the user in front. Now, the problems with this is that we only have the correctness of the gesture. The AirSig is only limited to telling you whether you're right or wrong with the gestures that you make. So we don't actually have an indication of are you going too fast or too slow. So that's why the accelerometer in the Vive controller comes in very useful. This is the next step that we took in the project, and we decided to start building a perfect model that which our users would compare themselves to. So we have this small struct called a conductor sample, and in it we store the velocity, duration, time, and beat. And we start recording that for every single frame that we start playing this track. Ideally, we give this starts collecting data from somebody who is performing the beat perfectly. And once it's all collected, we will now have like this huge list of just, this is perfect data, this is perfect 100 BPM, this is the ideal velocity at the right beat at the right time. Once we have all those collected lists, we can then have those stored while the experience is running in real time. And at each frame, collect a new conductor sample that we can then compare to the list that we've stored. Since we have these lists that we're comparing ourselves to, we can then define whether you're going too fast or too slow. The precise calculations are still something that is currently being discussed with another source in Metanaut called Reese Patterson, who's been giving a lot of feedback as to the speeding up or slowing down of the BPM. but it's a great step that we're taking, and we're hoping that it'll give some really good results. The calculations, although there might be a bit of the worry is that we'll be going down the list of our samples, and our velocity might be, if we go down the list of our samples while comparing the real time, it might take a bit too long. But luckily, because humans usually detect a difference in sound every 0.05 seconds, and we get a reading every 0.011 seconds, even if there's a little bit of latency, we have a good amount of leeway, and we're able to have a feedback that isn't actually as jarring as it could be. And yeah. And what's really exciting about the project is that I believe that there's a lot of different ways where it can go. While this has mostly been focused on the technical aspect of the movement of in this case, the Vive controller, there's also a lot of other aspects that make this experience appealing. One of them is, for instance, I would like to have the inclusion of spatial sound, which luckily we just had to talk about that. So that was very informative. Because right now the orchestra piece is just sounding straight out of your headphones. So we'd like the sound to come out from outwards. So if you're a conductor, we want you to have the experience of having the sound come in from away from you, as well as hopefully setting an offset for how close you are from the orchestra. We also like to change the skybox, although I am quite fond of the dark night with lots of stars. We'd like to create a 3D model of the Chant Center here at UBC. Once again, just for the aspect of realism. We also like to update the menu for something a bit more intuitive to follow. A lot of this has been, there's still a long way to go with this project, but I don't think it's slowing down. It is speeding up. We've gotten 2 new artists and 1 new programmer to join the team, and we trust that we can get started on a lot of these new features. Once we have everything set up, my intent is to hopefully generalize a lot of what we've been working on. So right now we've only had the 4/4 legato beat, and hopefully we can create a good system that can generalize a 3/4 and identify a staccato beat and have everything a bit cleaner and a bit more generalizable. And for more information, you can go to UBC EML website, and we've got a couple of articles posted on a few showcases that we've done in the past. And yeah, well, thank you for listening.